Then we are going to be working with standard form and slope-intercept form of linear equations. So our learning targets, we're going to write a linear equation in standard form, which we've done before, so that's just a review on that. We're going to write a linear equation in slope-intercept form given its slope and y-intercept. We're going to write a linear equation in slope-intercept form given its slope and a point on the line. We're going to be able to write a linear equation in slope-intercept form given 2 points on the line, and we're going to write a linear equation in slope-intercept form given a point on the line and an equation of a line that's either parallel or perpendicular to it. So just given some information and then be able to write it in slope-intercept form, and then a review on writing the linear equation in standard form. All right, just a reminder of what standard form there is. It's ax plus by equals c, where b and c have to be positive or negative whole numbers, and a has to be a positive whole number. So no fractions in there. Unlike slope-intercept form, you can't have any fractions in standard form. All right, so let's also review graphing this one out here. So this one's in standard form here, and we're going to go ahead and change that one here into slope-intercept form and be able to graph that out. So to do so, to get it in y equals mx plus b form, we're going to have to subtract 2x from both sides, and we get y equals negative 2x plus 3. So if you remember from our last lesson here, this is our y-intercept. That's where we start, so let's plot the y-intercept. So it's right there at 3, and then this is our slope. And if there isn't a number on the bottom, it's a 1, so we're going to put a 1 on the bottom. So this is your rise over your run. And remember, I usually like to put my negative up, but you could put it down as well. You just can't do both up and down when it has just a negative 2. So negative 2, I'm going to come down to, and then 1 to the right. Come down 2 and 1 to the right, come down 2 and 1 to the right. Remember, I could have also done that as positive 2 over negative 1. So then I could have risen 2 and run 1 to the left. Risen 2 and run 1 to the left. And then if I connect my points, whoops, kind of missed that last one. There it is. So now let's go ahead and just write the linear equation in slope-intercept form given some information. So our first information here is we're given the slope and the y-intercept. So when I see slope and y-intercept, I right away think, oh, slope and y-intercept, that's slope-intercept form. So y-intercept there is 2. That's the same thing as my b value. The slope is the same thing as my m value. So let's just put those 2 values in here. The slope is 2/3, that's an m. The y-intercept there is 2, which is a b value. So it says to write the equation in slope-intercept form. This is my slope-intercept form. And we've got the answer. So there we have it. Again, we've got the slope and the y-intercept. So let's just put the information into our equation. So y-intercept here is our b value. Our slope is our m value. So y equals, m there is our slope, which is a negative 1/2 x. And then y-intercept is a positive 4. That means a plus 4. So there we have it. So this one says to write the linear equation in standard form. So what's wrong with that first one? That first letter A there, y equals 3/4 x minus 2. That is in slope-intercept form. So we have to put that in ax plus by equals c form. So I'm going to go ahead and bring my positive 3/4 x over on this side by subtracting 3/4 x from both sides. So we end up getting negative 3/4 x plus y equals a negative 2. All right, so if you remember, Your B and your C values, that's in front of the Y and the constant term over there, those have to be positive and negative whole numbers, and they are. But the A value has to be a whole number, and it has to be a positive whole number. First of all, the A value there is not a whole number. It's a negative. It's a negative 3/4. It's also not positive. So to change that, we're going to multiply every single term in there by what's down in the denominator. But since it's also negative, we're going to multiply by the negative of 4 there. So we're going to multiply this term here by -4, this term here by -4, and this term by -4. So -4 times -3 there is 12 over 4. With 12 fourths there is 3x. And then this is a -4y. And -2 times a -4 there is a +8. So there we go with the first equation written in standard form. Letter B there, that's almost in standard form. It's an ax plus by equals c, but your a value here is negative, and it has to be a positive. Now, either the b and the c there, what's in front of the y, could be negative, and then your constant could be negative, but your a value has to be positive. So what we're going to do here to eliminate the negative in front of that, we're going to multiply every single term in here by a -1. So -1 times the -4x is 4x. -1 times y is a -y. -6 times the -1 there is 6. What about letter C? Well, the first thing I would do here is use my distributive property and distribute the -2 through the parentheses there so we can start seeing what's going on with this problem. So -2x minus 4. So I'm going to bring my constants over on the other side first because I know I have to get the constants over there. So I get y equals -2x minus 1. And then the x term has to be over by the y term, so I'm going to bring that over on the other side. So I'm going to add 2x, add 2x. So on the left-hand side there, we get 2x plus y equals a -1. So now, given some more information here, and we're supposed to write the equation in slope-intercept form. This time we're given a point and we're given the slope. Since we're given the point and we're given the slope, we can use what's called point-slope form. So let me show you what point-slope form there is. It is y minus y1 equals m times x minus x1. So here's my point. It's x1 and y1, and here's my slope. So we can plug everything in there. We can say y minus the y1, which is 2, equals m, that's your slope, which is 2/3, times x minus x1. And what's my x1 up there? It's 6. So we're supposed to write this in slope-intercept form in the end, and right now it's in point-slope form. So we're going to have to use our distributive property and distribute our 2/3 through. So you get y minus 2 equals 2/3 x minus, putting that over 1, 2 times 6 there is a -12, divided by 3 times 1, so a -12 divided by 3 there is a -4. All right, so put this in slope-intercept form. So I have to bring the 2 over, so I have to add 2 to both sides. And we end up getting y equals 2/3 x minus 2. So there it is in slope-intercept form, y equals mx plus b. So likewise, over here with letter B here, we're given a point, and we're given the slope. So let's use our point-slope form. So y minus y1 equals m times x minus x1. So what's my y1? It's my -1 up there. So y minus a -1 equals m, which is 1, times x minus x1, which is a negative 3. Now you've got a couple minus and minuses in there. So when you have a minus in there, you can make these pluses. You can distribute the 1 through. And so we end up over here. 1 times x is just x. 1 times 3 there is just 3. I can bring my 1 on over, and I end up getting y equals x plus 2. So our goal here was to get it in y equals mx plus b form. So we had to bring the constants over on the same side with the x. So it ends up being in y equals mx plus b form. All right, so now this time, the information we're given here is just 2 points. We're not given a slope at all. So because they gave us a point here, we're going to start here with point slope form. So again, I'm going to use this form right here, y minus y1 equals m times x minus x1. The thing here is I do not have the slope. So let's come over here and let's find the slope. So slope is equal to y2 minus y1 all over x2 minus x1. All right, so we're going to name these points. We're going to call this first order pair here. I'm going to do a different color here. We're going to call this one x1 and this one y1. Call this here. So here, I'll just put it over here. This is your x1 and your y1, and then 1, 4 is your x2 and y2. All right, so let's plug them into the equation over here. y2 there is going to be a 4. y1 there is a negative 4. All over x2 there is 1 minus x1 there is a negative 3. So again, we got that minus a minus going on over here, so this just becomes plus. And we get 8 divided by 4, and 8 divided by 4 there is simply 2. So it says y minus y1. My y1 there is a negative 4. So y minus y1 equals 2 times x minus x1, which is a negative 3. I have that minus a minus going on here again, so I'm going to change that to a plus, change that to a plus. So we get y plus 4 equals, I'm going to use my distributive property and distribute the 2 through, so I get 2x plus 6. And then the last thing I'm going to do here is bring my 4 over, so I'm going to subtract 4, and we end up here with y equals 2x plus 2. All right, so very similarly down here, my next problem here, I'm going to call this 3, negative 4, my x1 and my y1. And I'm going to call this negative 1, 2, my x2 and my y2. So I have to find the slope in this one first because they didn't give it to us. So the slope is equal to y2, which is 2, minus y1, which is a negative 4, all over x2, which is a negative 1, minus x1, which is a 3. So I've got that minus a minus there going on again, so I'm going to change that to a plus. And we end up there with 6 over negative 4. Reduce it down by 2. 2 goes in a 6 there 3 times. 2 goes in a negative 4 there negative 2 times. We just end up here with a negative 3 halves. So let's go back up here and use our point slope form. So y minus y1 equals m times x minus x1. So my y1 there being negative 4, and my slope there being negative 3 halves, my x1 there being 3. All right, we've got this minus a minus going on over here, so let's make that a nice plus. And then we're going to use our distributive property and distribute that -3/2 through. So we have y plus 4 equals -3/2 times x there is a -3/2 x. -3/2 times a -3 there. Remember, this is like a -3/1. And you're going to multiply your numerators and multiply your denominators. So -3 times a -3 there is a positive 9, and 2 times 1 there is a 2. So we get a positive 9/2. So it's still not in y equals mx plus b form. We're going to have to bring over our 4. So we're going to subtract 4 from both sides. So we end up here with y equals -3/2 x plus 9/2 minus 4, and it's over 1. I'm going to have to get a common denominator, which is a 2. And so y equals -3/2 x. 9/2 minus 8/2 is going to give me a 1/2. So it's a plus a positive 1/2. So there it is in y equals mx plus b form. So parallel lines and perpendicular lines. It's really important for us to understand what these parallel lines and perpendicular lines are all about here. So let's look at these here. Parallel lines, if you notice the 2 parallel lines down here, the examples that were given here, is if I take a nice ordered pair there and I go to the next nice ordered pair there where they're actually landing there, I can see that I'm rising 1 and running 2. So my slope in this case is 1/2. If I go to this line here, I'm rising 1 and running 2. So my slope here is also 1/2. So these are parallel lines. They'll never intersect, and you can see the distance between them here, the distance in between these are consistent all the way through. That, if you were to measure that every single time or figure out that distance there, it is the same at all times, that distance between those 2 lines, because those are parallel lines. You can also tell because the slopes are the same here. So something we want to say about parallel lines, they have the same slope. So parallel lines there have the same slope. We can also look at the perpendicular lines and see what kind of information we can find out about those. So let's do that one there next. So let's look at this line right here and look at its slope. And the next point would be right there. So I'm going to rise 1 and I'm going to run 2. So this line here has a slope there of 1/2. So then what about the other line right over here, this one here? So this one here is a nice ordered pair, is right there, and then we have one right here. So then I'm going to come down 2 and I'm going to run 1. So down 2, rise over a positive 1, which gives me a -2. We say that these have perpendicular lines have opposite because one's positive and one's negative. So opposite, one's positive, one's negative. And then reciprocal. And I'll show you what reciprocal means here. So if this one here is 1/2, reciprocal would mean that you flip it. So instead of 1/2, you would have 2/1. Those are reciprocals of each other, 1/2 and 2/1. Opposites is that this one's a positive 1/2 and this one's a negative 2. So one's positive, one's negative. Reciprocal, you just flip the fraction. So now we're going to be given some information about, we're going to give some information and then what it's parallel to. So in this case here, we're told that these 2 lines here have a point here in common here. They both have a point there well, the one line there goes through -3, -1, and it's parallel to this other line here. So they don't have a point in common because they're parallel lines completely. So we're going to call this point here x1 and y1, and we're going to just come over here, and the only thing we're going to do with this equation over here, this equation is y equals 2/3 x minus 1. Its slope there is 2/3. The only thing we're going to do with the equation that they give us is we're going to just look at its slope, right? So we have a point, we have -3, -1, and we have a slope, and it is 2/3. Parallel lines have the same slope. So since this one has a slope of 2/3, our new equation there has the same slope of 2/3 as well. So now that we have a point and we have a slope, we want to use the point slope form. So we've got y minus y1 equals m times x minus x1. So I'm going to plug in all the information we have. So y minus a -1 equals 2/3 times x minus -3. So we have those two minus and minuses there. So let's go ahead and put a plus in there and a plus in there. And then use your distributive property and distribute the 2/3 through. So you have y plus 1 equals 2/3 x, and I'm going to put this over 1. So when we distribute that through, that 2 times 3 there is 6, and 3 times 1 there's 3. 6 divided by 3 there is 2. Next thing I have to do is bring over the 1 because we want to put this in y equals mx plus b form. So you see that two equations are not identical. They have the same slope. The one we started off there with, y equals 2/3 x minus 1, this has a y equals 2/3 x plus 1. They're not identical. They're just parallel to each other. All right, what about if you're given some information here and you're told that it's perpendicular to a different line? Well, perpendicular, remember, the only thing that we're interested in is its slope. All right, so its slope there is 1/2. What's the relationship with perpendicular lines? They have opposite reciprocal slopes. So if one's positive, the other one's negative. So our slope over here, since this one here is a positive 1/2, ours has to be a negative. This one here is 1/2. What does reciprocal mean? It means you're going to flip it. So it's 1/2, so it's going to become 2/1. So our slope there is simply -2. All right. They also gave us a point. They gave us x1 and y1. So let's go ahead and put this in point slope form. So y minus y1 equals m times x minus x1. So my y1 there being -2. So y minus a -2 equals my slope times x minus x1, which is 2. We have 1 minus a minus there going on, so I'm going to change that to a plus. Let's distribute our -2 through over here. And so we end up here getting -2 times x is a -2x. -2 times a -4, minus -2 times a -2 there is a +4. Bring over the 2, so I have to subtract 2, and we end up there with y equals -2x plus 2. So again, perpendicular lines have opposite reciprocal slopes. So this one had a positive 1/2. Ours had to have a negative. That one had a 1/2. Ours had to be a 2/1. So -2/1 is just a -2. So you are now working on the 1-5 worksheet.